The universe is a place of unimaginable extremes. Among the countless planets scattered across the cosmos, there exists a class of worlds so massive, so extreme, that they defy comprehension. Imagine a planet so enormous that it dwarfs Jupiter, our solar system's giant, in both mass and scale. A world that pushes the very limits of physics, where gravity twists reality, where the atmosphere itself is a storm of unimaginable power. This is not science fiction, it is the frontier of astrophysical discovery. Welcome to the terrifying reality of the biggest planets in the universe. It all begins with the concept of mass. As planets grow, their gravity strengthens, pulling in matter, crushing gas layers, and shaping the world into a sphere of near-perfect symmetry. On Earth, we measure gravity in comfortable terms, a force that lets us walk, run, or jump. But on a planet that is 10 times the mass of Jupiter, gravity becomes a constant crushing presence. Standing on the surface, or more accurately, hovering in the outer atmosphere, since the planet might lack a solid surface, you would feel your body stretched, compressed, almost unrecognizable. Every step would weigh as much as a small car. Every breath would be a labor. Even a 70-kilogram human could feel as if they carried hundreds of kilograms of weight, making simple movements nearly impossible. And yet, mass is only the beginning. The composition of these planets adds layers of danger and wonder. Some are gas giants, immense spheres of hydrogen and helium, their interiors a maelstrom of pressures and temperatures that would vaporize any spacecraft long before it approached the core. Inside, hydrogen behaves not as a gas, but as a metallic liquid, conducting electricity and generating magnetic fields hundreds of thousands of times stronger than Earth's. These magnetic titans produce auroras that would stretch across continents, glowing with a color palette beyond anything human eyes have ever seen. Lightning storms rage continuously, fueled by atmospheric convection that has no equal anywhere in our solar system. To look at such a planet is to witness raw energy, concentrated on a scale that is almost incomprehensible. But some of the most terrifying planets are not merely large, they skirt the boundary between planet and star. These super-Jupiters, or massive gas giants, can reach masses tens of times greater than Jupiter, yet retain a radius only slightly larger. Here, the laws of physics take on a strange form. Adding mass no longer makes the planet bigger. Instead, gravity compresses the planet, making it denser, hotter, and more extreme. Internal pressures reach millions of atmospheres, enough to crush rock into exotic forms and turn gases into metallic liquids. The heat emanating from the core can rival the surface temperature of the sun, creating a planet that is literally glowing with raw energy. To witness such a world is to confront a force of nature so powerful that it feels almost sentient, a reminder of our own cosmic insignificance. Beyond the physics, there is the sheer scale. Imagine placing 50 Earths side by side, stacked like beads on a necklace, and still having the planet stretch beyond them. Imagine a storm so wide that it could engulf our entire planet multiple times over, spinning at hundreds of kilometers per hour. And imagine for a moment that this planet is not orbiting any star, wandering the galaxy as a rogue world, cold and dark on the surface, but seething with energy inside. Its very presence is a cosmic hazard. Stray too close, and even an unmanned probe could be crushed, melted, or obliterated in minutes. These are not places meant for life as we know it. They are titans of matter and energy, sculptures of gravity and pressure that exist in a domain utterly alien to human experience. The atmospheres themselves are equally terrifying. In some of these massive planets, hydrogen and helium dominate, but heavier elements are present in shocking abundance. Deep beneath the upper cloud layers, pressures rise so dramatically that materials behave in ways entirely foreign to our understanding. Hydrogen becomes metallic, able to conduct electricity like a liquid wire. Methane and ammonia form dense clouds that can crush any object passing through. Temperatures climb to thousands of degrees Celsius, enough to melt spacecraft hulls, and yet the upper layers might remain relatively cool, deceptive in their calm appearance. It's a world where the surface you can touch is an illusion, hiding a violent, glowing inferno beneath. One particularly mind-bending example is ROXS 42b, a planet so massive and so young that it still radiates the heat of formation. Its magnetic field is millions of times stronger than Earth's, producing auroras across an entire hemisphere simultaneously. Picture this, massive currents of charged particles racing along invisible magnetic lines, lighting up the clouds in colors that no human has names for. The planet itself drifts alone, not tethered to any star, a rogue wanderer moving through the galaxy in search of its own destiny. And yet, despite its isolation, the sheer energy contained within is staggering, a self-contained engine of physics at the very edge of what is possible. And it does not end there. The line between planet and star blurs with brown dwarfs, objects too massive to be called planets but too small to sustain nuclear fusion like stars. Some of the largest planets transition into this territory, teetering on the edge of ignition, their cores hot enough to fuse deuterium briefly before cooling again. These hybrid objects are sometimes called failed stars, yet they exhibit characteristics both terrifying and mesmerizing. Imagine a body so dense that its gas envelope is compressed into metallic layers, yet it retains the scale and rotation of a planet. Any probe attempting to map it would need technology far beyond our current capabilities. And yet, astronomers can detect them, charting these colossal worlds through the light they distort, the stars they tug upon, and the gravity they exert on neighboring objects. Living on or near one of these planets is pure fantasy for humans. The gravitational pull alone would make locomotion almost impossible. A simple jump could launch you hundreds of meters into the air, only for gravity to snap you back down with a crushing force. The atmospheric pressure, heat, and radiation would render unprotected exposure instantly fatal. Even imagining a colony in the clouds, floating on thick hydrogen layers like futuristic cities suspended in air, challenges every law of biology, architecture, and human endurance. And yet, these planets continue to exist silently, without concern for the life they cannot support. The terrifying beauty of these worlds lies in their scale and unpredictability. Their storms are global in reach, their magnetic fields warp space around them. Their very mass bends light, creating lensing effects that can distort distant galaxies for astronomers far away. They remind us that our understanding of planets is still in its infancy. We can measure, simulate, and theorize, but the reality of standing on such a world, feeling its weight and power, is almost unimaginable. It is a testament to the extremes that nature can achieve, sculpting objects that exist at the very edge of possibility. And then there is the philosophical dimension. A planet so large and so intense makes humans feel utterly insignificant. On Earth, we measure size, mass, and energy in terms we can comprehend. But a super Jupiter or a rogue massive planet laughs at our scale. It does not bend to our perception or our definitions. It simply exists. Our experience of time, space, and force is dwarfed, almost irrelevant, in comparison to the raw, unyielding presence of such a world. To gaze upon it through a telescope is to confront both awe and terror simultaneously. Perhaps the most unsettling thought is imagining what could lurk on the periphery of these giants. Moons larger than Mercury, rings thousands of kilometers wide, intense radiation belts, all contribute to a system of forces that challenge physics and imagination alike. Planets this massive could capture smaller planets, flinging them across space or stripping them apart entirely. They are architects of chaos, shaping their own miniature systems with rules dictated purely by gravity and mass. Their influence extends far beyond what we consider their surface, reaching into neighboring space, affecting stars and gas clouds, bending trajectories in ways that could last millions of years. Yet for all their terror, these planets are a testament to the beauty of the cosmos. The colors, the auroras, the swirling storms, they are paintings of physics on a grand scale. They are worlds that challenge human perception, pushing the boundaries of what we can imagine and understand. They exist as living examples of the extremes that the universe allows, objects that are neither good nor evil, simply magnificent in their scale and power. As we continue to explore, catalog, and simulate these giants, we begin to understand the delicate balance of forces that hold them together. Gravity, pressure, and heat interact in complex ways, sometimes violently, sometimes in harmony, creating worlds that are both terrifying and beautiful. And while humans will likely never walk on these planets, our observations and simulations allow us to glimpse the sheer scale of creation, the boundaries of possibility, and the awe-inspiring might of the universe. From tiny worlds smaller than Mercury to gas giants that challenge the very concept of what a planet can be, the cosmos continues to surprise and humble us. The biggest planets are terrifying, not just because of their size, but because they expose our limits, our understanding, and our imagination. They remind us that the universe is far bigger, far stranger, and far more powerful than we can ever fully comprehend. So, the next time you look up at the night sky, think of the giants lurking in distant systems, silently spinning in darkness. Think of the storms, the magnetic fields, the crushing gravity, and the unimaginable heat. And ask yourself, if the universe can create something this massive, this extreme, what else is out there, waiting to be discovered? The universe is full of wonders, but few are as simultaneously beautiful, incomprehensible, and terrifying as the largest planets. They are a reminder that no matter how much we learn, the cosmos always has new extremes to challenge us. And in the case of these massive worlds, extremes that make our wildest imaginations seem tiny by comparison.